Hey, what is good, you guys? Welcome back to the channel. So, the 2026 FIFA World Cup is just days away, and I thought it would be a fun project to build something around it. So, we're going to do two runs of this. One is a prediction engine version, and the second is a machine learning and AI version. So, what we'll do is we'll try to predict the winner of this World Cup using, as I mentioned, firstly, building a prediction engine of our own, and secondly, using machine learning as well as AI. So, let's get started. Right. So we are going to start with the data sets which we need. So there's two data sets which I've used. One is from Kaggle, which has the international football results from 1872 to 2026. It is quite comprehensive. It has a results.csv, shootouts, goal scorers, and former names. So countries whose names have changed in between or things of such have happened. Out of this, we're going to use the results.csv. Okay, the others are, I mean, we can use it in a later date, but let's use the simplest one first. The second one is this one. It is on GitHub and it has the World Cup teams. That is basically the teams which have qualified, and there is a World Cup. 1 minute. Okay, there was one which had schedules. Okay, let me search it quickly. Okay, sorry, it's here only. It's worldcup.json. This is where the matches are. Okay, so this data set is enough. Using this, what we're going to do is we're going to divide this video into two parts. The first part is a non-machine learning based simple system where we build a ranking system, or we basically try to do it without AI/ML solutions and try to predict it. So we'll try to predict one tournament, that is one simulation, but one is never good enough. And what we're going to do is we are going to use something called as Monte Carlo simulations. And in the Monte Carlo simulations, what we'll do is we'll run X number of runs and see finally who is the winner. Okay. So let us see the code. I'm not going to show the entire coding; it's boring. But I will show you the most important parts which I've written. So as I mentioned quickly again, we have the data set which is results.csv. So we don't need data from 1872. Okay, I think it's too much data. So what I have done is basically if you go to somewhere around calculate team ranking and load historical matches. So here somewhere, yeah, so recent cutoff. So I've taken this from the 2000. So the World Cup was in 1998, I think. So since then, or the turn of the millennium, that is when I've taken the data sets from. We won't go back. I don't think we need data that far back, but we can try, or you can try it. I'll upload the code and you can try it. So the entire code base. So I'm currently on the main.py. Okay, so this is the main.py, and it has this is where our code base starts. So if you are new to Python and you don't know what the main.py does, then I think yeah, back to the basics for you. But anyways, so we have around 4 or 5 major parts. If we include the main, we have 5 major files. The main is basically where the calling happens. Then we have something called as the predictor.py. We have the core logic, which is the ranking engine, and then we have the Monte Carlo.py. So what happens in the main, as I mentioned, this is just a calling, and everything gets started from here. So in the main, everything gets started. In the ranking engine, so as I mentioned, this is not a machine learning based solution. We are building a custom ranking solution, and we want to pitch this custom ranking solution against an AI/ML based solution. So we'll see how good a ranking engine we can build. So what I've done is, firstly, load historical data. So as I mentioned, we take the old data from results.csv and we filter out all data older than the 2000, the before the millennium. Basically, we don't want data, so only consider data from that. So once we do that, load historical data. Let me go back to the main.py in calculate team ranking. So what we do is we so if you look at the data set, what happens is in the, let me open this again, there are some names here where they refer to a non-standard version of the country. So for example, Turkey can be called as Turkey, and or maybe there are other names. USA could be United States of America, or the US or USA. So there could be naming, there are naming issues somewhere. So I've done that as well. So now the most important part which you need to know is how we are calculating the ranking. So for each team, we give a strength. So based on the matches, the win percentage, how many goals they have scored, and how many goals they have conceded. So this is like the core data. Now this is taken from the entire history. But what I've done is to make it more not reliable but more relevant. I've taken the most recent matches of those qualified teams. So, for example, Portugal is in good form, or maybe Argentina and Spain, as always, they are in good. I don't know or Argentina honestly, but Spain are in a good form. So I've taken the recent form as well. So the stats are then joined to the recent form. So basically this, and what it does is we give a strength to the team. So based on the win percentage, goals, defensive score, and recent form, we calculate the strength of the team. And based on the strength, we give them a rank. Okay. So we display all of them and we give each and every team a rank. So this is the first part. Now, once the rank is done, this is just to show the ranking. Okay. So if I just do let me do a quick run of this one. Okay. So let me run the team ranking thing. Okay. So here, this is how it works. So it's given Spain the number one rank. The normalized name is also Spain. So 343 matches since 2000 or the turn of the millennium. 68% win percentage, which is good. They've scored 2 goals on an average, conceded zero point 0.7, and they have a strength of 0.9. Okay. And this follows. So Spain, France, Brazil, England, Argentina, these are pretty big names, and the result more or less aligns with the team ranking, or we know that these are the strongest teams. Brazil is a bit of an outlier, but as I mentioned, this is from the 2000s, so it calculates a little bit of historical data, but we have tried to give it the recency bias as well. Right. The next important one is the simulated tournament. So how the World Cup works is this time there are 48 teams and approximately 104 matches, I think. So there would be the group stages. Then there would be the knockout stages. So knockout stages are basically your round of 32, 16, and stuff like that. So each the opponent gets knocked out. You don't get a second chance. In the group stages, each team plays 3 matches, and the top two progress to the next round. So when we go to the simulate tournament, we calculate the team ranking again, the one which I showed you, and that ranking is passed as it to the tournament simulator, which then loads the schedule and it simulates the tournament. So simulation is done for knockout stages as well as the group stages as well. Here somewhere, this one. Okay, so we simulate the group stages and the knockout stages. So the last and the most important part is Monte Carlo simulation. So it's a general concept where you run multiple simulations of an event and then get a better idea. So for example, what we're going to do is we can, by default, we are going to run 1,000 simulations, but you can run more than that. We will see and look how the output differs. So for example, we run 1,000 simulations, and out of that, Spain comes out as a winner for 180 times. Then Spain has an 18% chance of winning the World Cup. So if you run it for 10,000 times and 100,000 times, so on and so forth. So that is how the code works. I will share the links to all of this on a GitHub repo. But let us now run this. Okay. So let me run the main.py. So I'm going to run it with all the defaults. So here the defaults are simulation, 100 simulations. There is no seed assigned to it. There's a 42 over there. So I'll show you what happens with the seed as well, and the default inputs as well. So if something changes and no animation, I'll show you why it's done. So I hope the outputs are visible. Okay. Yeah. So in a single run, or Portugal is coming to out to be the winner. Okay, this one. Let me let me maximize this. Okay, so Portugal is coming out to be the winner, which is something which I want this time because Messi's won it already last time. And let us see so now it's doing the Monte Carlo simulations, and let us see who comes out to be the winner overall. Whilst it does that, so the top 20 team rankings, these are more or less similar. Okay, so these will come out to be the similar because these are the best teams currently. So in the group stage A, Mexico, South Africa, South Korea, Mexico and South Africa are to be the winners. So these are the qualifiers, and 3 points. So similarly, the multiple qualifiers, and for the round of 32, round of 16, these are the results. And the semi-final, here it says South Africa versus Qatar, Ivory Coast versus Portugal. and eventually Portugal comes out to be the winner. So this is kind of the problematic version of running only one simulation, or one problematic of building our own prediction engine as well as running a single simulation. But now the Monte Carlo simulation is done, and Spain has won 74 out of the 1,000 ones. Out of the 1,000 simulations, England has won 67, Brazil has won 57, and so Spain comes out to be the winner with a 74%, 7.4% chances, which is a good number, and which I think could also be true because they are a pretty strong team. So now let us run it with a different simulations. Okay, simulations as, say, let's say 10, and it is running 10 simulations, and the winner is Brazil. So if you run it with a different seed, say 5, Australia is coming out to be the World Cup. So this is how the seed and the simulations, what do you say, influence the output. But if you run it for a large number of simulations, say 1,000, 10,000, or even 100,000, let us see what actually happens. It will take some time to run. Okay. But it is also important to know, if you don't give the seed. Now if you give the seed, this result would have always come out to be Portugal. So I'll show you that as well. But if you don't give the seed, then what happens is, this champion also gets randomized. So a single run also gets randomized, and you pick a random champion. So it's still running. It's taken a while actually. I should have honestly just run it with 10K simulations, but yeah, I'm going to wait for this one. I'm interested in the output actually, who wins it. I hope it's Portugal. The 100K simulations is definitely messing this up bad. Not messing this up, but just taking a bit much longer than I expected. Okay, so the problem was with the way I was storing these simulations. So for entire run, it was trying to store the 100. What you need for the Monte Carlo simulation is just the winner, right? But what I was trying to do is store the entire 104 matches for every run. So that's why it was taking around 43 seconds for 1,000 simulations. So multiply it by 100,000, and that's why it was taking some time. So I made some optimizations. Let's see how this works now. So let's see, and predicted winner is Spain again for 1,000 simulations. Let's run it for 10,000, and this time. So let us see. The champion this time came to be Morocco. Let's see who it was last time. It was Switzerland. Not the best, but yeah. So this is for 10K runs. Okay. No. So what? And the winner this time is Spain again. I'm pretty sure they're going to win this one. I wanted to be Portugal. So one last simulation for. Let's do 50K first. Okay. Or 25K. I will increase this step by step to just see how the performance is. Otherwise, it will take too long. So this time, single tournament was Croatia. Last time they played pretty good, and so let's see. I don't think they're going to come this time, but yeah. And the final also says Czech Republic, which is very unlikely. Many things can happen, but yeah. So this time the winner is again coming to be Spain. They have a very high chance. So Portugal are not coming to be where they want, where I want them to be. But let's do one last try with 1,000, 10,000, 100K. Okay. And I'm pretty sure it's going to be Spain again, but because that's how the recent form is. They have the winners of the European Cup as well, I think this time. So they have a pretty good recent record. So that's why I want to build ML based solution as well. So we'll compare how the ML based solution does against this prediction engine, because the prediction engine has a lot of my bias in it, or how I've decided to build the ranking system. So which is basically the win percentage, that is number of matches they won, the goals they scored, and Spain scored too many. Portugal score, but they also concede. Spain are like single-handedly dominating games with Lamine Yamal and all those in that team is pretty strong anyways. Okay, it is now running, and again, as I expected, the winner is coming to be Spain only. So let me pull this a little bit up, and out of the 100k, 8300, and the margin is growing. So this is now 83% win, no, 8.3% win probability, with them winning 8300 of the games. Let us see how much it was. It was 8. So roughly the prediction is also same. So it doesn't matter how many runs we do. The probability is coming to the same, because again, behind the scene, it's just static metrics, right? The number of goals scored, the number of the win percentage, and all that. So this is one downside of building a ranking engine. It is very dynamic, and even with multiple simulations, this has a potential problem. So in the part two of this video, what we're going to do is we're going to use an AI ML based solution, pull in the latest data, as well as avoid this hard coding logic of ranking and everything, and see how that one goes. So stay tuned for the next video.